Hello everyone. In this video, we'll be looking at nitrogen, and then in subsequent videos, we'll be looking at compounds of nitrogen such as ammonia and also the oxides of nitrogen. Now, you will recall that air, we usually define air as a mixture of gases. And the gases that make up air are nitrogen, N2, nitrogen, oxygen, carbon dioxide, and then you have your noble gases. So from here, we already see that nitrogen is a constituent of air and is actually the main constituent. Air is actually 78% nitrogen. Now, we also find nitrogen in living organisms in the form of protein, urea, and in vitamin B compounds. I've put a chart here of common vitamin B compounds. So this is vitamin B1, and you notice it has 4 nitrogens. This is vitamin B3, and it has a single nitrogen. And this is vitamin B12 with 14 nitrogen. So nitrogen is always present in vitamin B compounds. We can also find nitrogen in the earth crust in the form of trioxynitrate 5 salts of sodium and calcium. That is, you can find it as a sodium trioxynitrate or as a calcium trioxynitrate. So what have I said so far? Nitrogen is one of the constituents of air, and it's also the major constituent because air is 78% nitrogen. We find nitrogen in living organisms in the form of protein, urea, and vitamin B compounds. And we find nitrogen in the earth crust as sodium or calcium trioxynitrate 5 salts. Now, what are the physical properties of nitrogen? Nitrogen has no taste, color, or odor. Okay, nitrogen is tasteless, colorless, and odorless. Nitrogen is slightly soluble in water, and it has a boiling point of minus 196 degrees Celsius. This is what makes nitrogen a very cold gas. Okay, because you think about it as a number line, this is 0 degrees Celsius, which is the freezing point for water. So you see, below 0, we start to have minus 1, minus 2, up till minus 196. Okay, so nitrogen is actually a very cold gas. Now we'll look at the chemical properties of nitrogen. Okay, now to understand the chemical properties of nitrogen, we have to take it from the periodic table. Nitrogen has atomic number 7. Okay, that means 7. That means nitrogen has about 2 inside, 5 outside. So nitrogen is going to have 5 electrons outside, which would denote as 1, 2, 3, 4, and 5. So if we bring in another nitrogen, so that will be plus another nitrogen, 1, 2, 3, 4, 5. We'll create something like this. Let me make this bigger. We'll create something like this. Okay, and if you remember your atomic structure, 3 lines like this, a line like this is 2 electrons. So this is 2, 4, 6. And then we'll have an extra 2 at the top, making 8 for each. Okay, so from here you can see that, and this is what we call N2, by the way. Whenever you see us write nitrogen as N2, this is what we mean. And in chemistry, we say nitrogen is diatomic, meaning you need 2 of them to make a single molecule. Okay. Okay, I don't think you have seen this properly, so let me redo it so that you actually get it. Although you should have done this in your periodic table and atomic structure. So this is what I mean. Nitrogen has atomic number 7. So if you have atomic number 7, you know, if you are drawing your shell structure, you have 2 electrons inside. So you are going to be left with 5 electrons outside. So nitrogen is going to have 5 electrons. To make it simpler, I'm just going to put 2 at the top and put those 3 electrons here. So altogether 5. And I can bring another nitrogen and do the same. So 2 electrons again, and then 1, 2, 3, making 5. When they combine, 2 again, I'm going to join each of these 2 electrons with a single bond. Okay? And then 2 again. So this is it. So nitrogen is diatomic. Okay? We need 2 nitrogens, which I said we call N2, to form a molecule. Now you will notice that nitrogen has 3 single bonds, and that's why nitrogen is very stable. The nitrogen molecule N2 is actually very stable, and so sometimes you hear us say things like nitrogen is relatively unreactive. Okay, so for nitrogen to react, you normally require high temperature and pressure so that these 3 bonds can be broken. Okay, so these properties I mentioned here, this nitrogen reacts with metal to form nitride or reacting with hydrogen to form ammonia, they usually occur under high temperatures. Okay, now having said that, at high temperature and pressure, nitrogen can react with metals to form nitrides. Okay, for example, we could have a metal like magnesium. This is a solid reacting with nitrogen. This is a gas, and we are going to create magnesium nitride. So I'll put a 3 here to balance it up. We'll create magnesium nitride. Okay. Other elements that could also, other metals that could also react with nitrogen are metals like calcium and aluminum. Okay. But basically, we just say when nitrogen reacts with metals, it forms nitride. Now, nitrogen can also react with hydrogen to form ammonia. So we could have nitrogen, a gas, and hydrogen, a gas. This reaction is reversible, meaning it can go both ways. And then we'll have ammonia, a gas. So to balance this up, I'll put a 3 here so that I can put a 2 here. Okay, so those are the chemical properties I want you to remember. Nitrogen can react with metals to form nitrides. Nitrogen can also react with hydrogen to form ammonia. Okay, now having said this, I think I should mention something about the oxidation state of nitrogen. So let me take all this off. Oxidation state. Oxidation state of nitrogen. Okay, now in chemistry we like to say that the oxidation state of nitrogen is between -3 to +5. The oxidation state of nitrogen is between -3 to +5. Let's use a number line to show what I mean. If I were plotting a graph, I'll have my 0 here. So this will be -3, -2, -1, and then 1, 2, 3, 4, and 5. So that's what I mean. The oxidation state of nitrogen is from -3 to +5. In other words, the oxidation state of nitrogen can be -3, it can be -2, it can be -1, it can be 0, 1, 2, 3, 4, or 5. It cannot be -4 because that's not in this range, or say +6. Okay, and the reason for this range, or a simple way to remember this range, is to look at nitrogen. See, nitrogen, we said it has 5 electrons in the outermost shell. It has 5. I'm drawing it this way now. It has 5. So in order to attain stability, nitrogen can give out this 5. So giving, that's +5. Or nitrogen can accept 3. That's -3. Giving is positive, accepting is negative. Okay, so the oxidation state of nitrogen can be anywhere from -3 all the way to +5. Now let's see the laboratory preparation of nitrogen. How do we prepare nitrogen in the lab? The first method I'm going to discuss is decomposition of ammonium dioxonitrate 3. Okay, NH4NO2. You apply heat and you get nitrogen, N2, and you get water, 2H2O. Okay, so don't forget, for these equations, you can always pause the video and write them out. So this is what we call decomposition of ammonium dioxonitrate 3. And by the way, the triangle at the top here means heat was applied. So this is actually a thermal decomposition. Now, sometimes because heating ammonium dioxonitrate 3 can be uncontrollable, we take a mixture of ammonium chloride and sodium trioxonitrate. Sodium dioxonitrate. If you observe well, if I combine these two, I will have combining these two will give me 4 and then NO2 plus sodium chloride. Okay, so sometimes heating ammonium diisonitrate 3 is uncontrollable. The decomposition can be very energetic and uncontrollable. So instead, you mix ammonium chloride and sodium diisonitrate 3 and heat that instead. So you are actually heating their products indirectly. Okay. The second method of preparing nitrogen is from the oxidation of ammonia. So I'll take ammonia NH3 and I'll use an oxidizing agent like copper oxide, and then I'll form my nitrogen, and I will also form water, and I'll form copper. Okay, so to balance this out, let me make copper 3, so that here is 3, and so that here is 2, so I can have N2, so that here is 3. So I form nitrogen again by oxidizing ammonia. Another method I can use to form nitrogen in the lab is by reduction of laughing gas. That is by removing, when I use reduction here, I mean removing of oxygen from laughing gas. Laughing gas is dinitrogen 1 oxide, that's N2O. So I can use a metal such as copper. So copper helps me to take the oxygen, and then I'm left with nitrogen. So 3 methods: decomposition of ammonium diisonitrate 3, oxidation of ammonia, reduction of laughing gas. So you could see questions like the oxidation of ammonia produces, your answer will be nitrogen. Reduction of laughing gas produces, your answer will also be nitrogen. Now, because it is a very useful gas, sometimes we want to prepare nitrogen in large quantities. That is, we want to prepare nitrogen industrially. And we do that by fractional distillation of liquefied air. Let me bring it out again. Air is a combination of gases. So air has nitrogen, air has oxygen, air has carbon dioxide, and air has the noble gases. So in order to get nitrogen from air, you condense the air, that you liquefy it, and then you remove CO2. To remove CO2, you use caustic soda. Okay, so caustic soda helps to remove CO2. That leaves us with nitrogen, oxygen, and the noble gases. Now, you can make use of fractional distillation because nitrogen and oxygen have different boiling points. See, nitrogen boils at -196, oxygen boils at -183. Okay, so they have different boiling points. So you could separate the nitrogen and oxygen using fractional distillation. Now, after separating, we have removed oxygen, we have removed CO2. The nitrogen left is still contaminated by noble gases. And this is why nitrogen gotten from industrial preparation is usually about 1% heavier. And this is very important to remember. Nitrogen gotten from liquefied air is heavier than nitrogen gotten from, say, decomposition of ammonium diazonitrate, reduction of laughing gas, oxidation of ammonia. And it is heavier because of the presence of noble gases. You see, we didn't really separate these guys out. Okay? So, in summary, to prepare nitrogen in the industry or in large quantities, we remove CO2 using caustic soda, and then because nitrogen and oxygen have different boiling points, we can use a separation technique called fractional distillation. Since noble gases are still with the nitrogen is going to be heavier than pure nitrogen. Now let's look at something interesting called the nitrogen cycle. Okay, in nitrogen cycle we are looking at how nature recycles nitrogen. Okay, how nature recycles nitrogen, and it starts right here from the atmosphere, where nitrogen makes up about 78%. Okay, now this nitrogen in the atmosphere, remember we said nitrogen is relatively unreactive. This nitrogen in the atmosphere does not really react. Okay, so what happens is that it undergoes a process called nitrogen fixation. Okay, so nitrogen fixation is where living organisms such as rhizobia or lightning help us to break down atmospheric nitrogen and then helps us to turn it into ammonia or ammonium. So you break the bonds in the nitrogen so that elements like hydrogen, as you can see here, can bond with it. And I said that process is called nitrogen fixation. And nitrogen fixation can be caused by living organisms such as rhizobia or lightning. Okay? Then when nitrogen is in the form of ammonia or ammonium, it undergoes a process called nitrification. So in nitrification, we are converting ammonia to nitrates. So that's why we call it nitrification. We are converting ammonia to nitrates. And the living organism that help us do this, we usually call them nitrifying bacteria. An example is your Nitrobacter. Now, when nitrogen is in the form of nitrates, two processes occurs. In this form, plants can assimilate it, as you see here. So this is one of the possibilities. Plants can assimilate it. When plants assimilate it, animals eat the plants. And when animals die, decomposers act on them to turn the nitrates into ammonia, and we call that process ammonification. The conversion of nitrates into ammonia by decomposers is called ammonification. Now, any of those nitrates that was not absorbed by the plant can be converted back to atmospheric nitrogen, and this process is called denitrification. Okay, so there is nitrogen fixation where atmospheric nitrogen is converted into ammonia by bacteria or by lightning. The ammonia is converted into nitrates. One of the things that can happen to the nitrates is that plants assimilate it, and then that gets it to the animals, the animals die, and then that nitrate is converted to ammonia in a process we call ammonification. Another thing that happens is that the nitrate can also just be converted back to atmospheric nitrogen by a process called denitrification. Okay, and I've summarized it here. You can pause it so that you get the definitions. And so we'll end with the uses of nitrogen. What is nitrogen used for? We can use nitrogen as a cooling agent because of its low boiling and melting point. Okay, so nitrogen is a very good cooling agent. Because nitrogen is a cooling agent, you can use it as a preservative. Just the same way you use your freezer as a preservative. Then number 3, nitrogen is used in gas chromatography. In gas chromatography, nitrogen is part of what we call the mobile phase, where it acts as a carrier gas. And also, although I didn't put it here, nitrogen in air serves as a diluent. Okay, that means nitrogen helps to moderate processes such as combustion. If there were no nitrogen in air, the spark of a match can turn into an inferno. Okay, so nitrogen acts as a diluent. Nitrogen acts as a diluent. Okay, so that will be nitrogen. In a subsequent video, we'll look at ammonia. Okay, but until then, don't forget to like, share, and subscribe. And this is all of us from Covenant Science Tutorial, wishing you all the best.
Hello viewer, if you find this video helpful, just as every other video on this channel, do well to like, subscribe to the channel, and hit the share button so we can get a wider coverage of viewership. Thank you very much. And also, this is to notify you whether you are viewing from Nigeria or outside of Nigeria that the Covenant Science online tutors are at your service. For science foundational classes in mathematics, the use of English, chemistry, biology, and physics, we've got you covered. Do well to contact us in the comment section, as our admins will be waiting to respond to you. Thank you once again, and don't stop watching Covenant Science Tutorial YouTube channel. Do have a lovely time.